How's it going, guys? Madiator here with a brand new tutorial. Today we're going to be doing a basic movement. To do the player movement, we're going to be using Unity's built-in character controller and making our own script to power this controller. To make the camera function, we're going to be using the scene's main camera, and we're going to make our own script to get the mouse input to shake the camera around when the player moves it, and as well as lock and unlock the mouse so you can play with the UI. Let's get into it. So what we're going to do is we're going to go back into our project that we made in the last episode with the notification system. We're going to create a 3D object of type plane, and we'll simply just name this ground. We'll change it off of 2D mode that we were previously on, and we'll focus on the ground here and reset its position to 0, so it's the center of our map here. I'll then focus on it again. Press F to focus. Now what I'll do here is I will create a new material to put on the ground. I'll just simply call this ground material and set the albedo to maybe some kind of like a dark earthy tone to represent dirt. I'll then just set the smoothness to 0 so that it just looks as simple low poly as possible, just to get the idea of what we're going for here. Then I will add a capsule. This will act as the graphics for our player. Just for now. I will also add an empty game object called player. This will be the parent object for all of our player objects. I will parent it to capsule and put our scene camera as a child of the player as well. Here I'm setting the player to just quite simply be above the plane so that it can collide with the plane and move around. I'm also going to reset the position values to 0, 0, 0 for X, Y, and Z. Leave Y as 1 so that it can still sit above the plane. Then I am adjusting the camera to be a simple third-person camera that sits behind our player. Then I'm just slightly adjusting the scale of the ground so that we have more room to walk around once we have set up the movement properly. Under our parent object, I'm going to add a character controller. This is what's going to handle the movement for our player. Here I'm simply just adjusting the radius and height to fit around the outside of our graphics. This can be changed later on once we have a 3D model to better represent our player. Once you've finished, you'll remove the capsule collider. We won't need that anymore for our graphics. And here I'm just putting the final touches on the radius for the character controller. I then playtest just to show that the camera is sitting behind and that the notification system is still working, which we'll use later on. We're then going to add a component of a script value. I named this PlayerController. You can name it whatever you want. Heading into the editor, we're on the PlayerController C# script. Let's start by making some public variables. First, I'm going to add a public float of current speed. This is going to keep track of the speed that our player is currently going and the desired speed of the player's movement. Then we're going to create some private variables. The first one will be a vector3 of current velocity. This won't be used in this episode. This will be used in the next episode when we add more functionality to our player controller, adding jumping and such. Then we will add a character controller variable and just name it controller. Under the start tab, we will now instantiate our controller by saying, just like in the last episode, get component character controller. This will get the component within our parent object of player, which this script is under. Here, I'm simply just creating a function called update movement. I like to keep my update functions very clean and only containing sub-functions. Here we are going to create a void update movement to hold the logic for our movement script. Here we'll create a float. This will hold the X input. So we will call input.getAxis horizontal. This will fetch Unity's built-in input system or whatever custom key maps you put for your horizontal input. Then we will say float z is equal to input get axis vertical. Horizontal will handle our left and right, and vertical will handle our forward and back. Then we will cast the movement to a vector 3. We will call this new movement, and we will set it equal to the transform right times our x input. The transform right is our right vector of our player's transform. We will then add onto it transform forward times our z input. Transform forward is the forward vector of the player's transform. What this does is this gives us a direction we are heading in multiplied by the input to figure out the proper, are we moving forward, are we moving back, are we moving left, are we moving right, are we moving diagonal in any of those directions. This will calculate all of that simply with that equation. So now we will check if the controller is valid, not null. Simply just say if controller does not equal null. Then we will apply the movement. So we will say controller.move to call the character controller's move function, and we will pass in new movement as our vector. We will multiply it by our speed, and then we will multiply it by time.delta time. Delta time will be further explained in a future episode as well if you're interested in learning more. Heading back into the editor, we can go under our player parent and see that the controller script is populated. Now, watch the positions at the top. When we press our inputs, we can see the positions change as well as the graphics moving around on the plane. You can see simply pressed left, pressed right, and such like that. Now under the camera, we will add a component. We will add another C# script. I named this PlayerCamera. You can name it whatever you like. Heading into Visual Studio again, under the PlayerCamera C# script, we're going to make some public variables. The first public variable will be a float, and we will call this mouse sensitivity. This can be set in the editor to change on the fly the sensitivity of the player's mouse movement. We will also add a public transform, and we will call this parent transform. This we will also populate in the editor to be a reference to the parent game object that is empty, simply so we can find the transform of it. We will add a float x rotation, defaulted to 0, a float mouse x, and a float mouse y. Finally, we will add a boolean, and this will be called is mouse locked. This will control our mouse lock state, which we will go over in a bit. The x rotation will be our up and down, the mouse x will be our mouse x input and position, and our mouse y's input position. Is mouse locked will control the lock state of the cursor if it's locked in the center of the screen. Under the start method, we will want to immediately lock the cursor to the middle of the screen on default. We will create a public void lock cursor, public so that we can call it from other scripts if they ever need to unlock or lock the cursor. Here we will call cursor.lockState and we will set it to cursor lock mode locked. Then our control variable is mouse locked. We will set it to true. Every open needs a close, so let's go ahead and create another public void, and we'll have this say unlock cursor. Quite simply, this is the exact opposite as the past function. We'll say cursor lock state equals cursor lock mode dot none. There is no lock state. Then our control variable will set it to false. Under update, we will need to check if the mouse is locked so that we can apply our mouse movement. If it is unlocked, the player might be in a menu or something of the such, and we don't want the camera to be flying around while the player's in their inventory. So if the mouse is locked, we will update our mouse look. To create this function, we'll call void update mouse look. This will only be called locally. To start, we will update the mouse positioning. We will populate mouse X to the return value of input.getAxis mouse X. We will then multiply it by the sensitivity and by time.delta time. We will then copy and paste it and just change X to Y so that we can populate our mouse Y variable as well and have both axes covered. Next, we will invert the Y axis. Here we will say X rotation minus equals mouse Y. Next, we will clamp the Y axis between a minimum and maximum value so that the player can't flip the camera past the desired range. This will vary based on your game style and how you want the game to be played. We will call mathf.clamp. We will have X rotation as our value. We will create a new range of minimum, so we will call this min lookup, and we'll call the maximum max lookup. We will need to now define these variables so that they can be applied. We will create a public float min lookup and default it to -90. We will also create a public float maximum lookup, and we will default this to 90. These can be changed in the editor based on your preferences. Next, we will apply the vertical rotation we have just clamped to our camera, which is our local transform. So we will call transform.localRotation, and we'll set it equal to quaternion.euler, X rotation, and 0, 0. We are only going to pass in the X value of this rotation. Next, we will apply the horizontal rotation to the player. This will be our parent transform that we set before, and we will just make sure that it's null before continuing. So then we will say parent transform.rotate, and we will pass in our vector 3 up, and then we will multiply that by the mouse X input. Next, I'm going to add a input function. I'll just simply call this update camera input. This function will control any camera input such as locking, unlocking the camera, zooming in or out, which we will go over zooming in and out in a later episode. So we will check for our desired key press. For the input, I chose tab, which is keycode.tab. We will then, after the button has been pressed, check if the mouse is locked. If the mouse is locked, we will unlock it. And if it's not locked, we'll lock it. We're exactly just switching to the opposite of what it currently is. Later, we can make some kind of control variable to ensure that this doesn't happen when we're already in a menu or something of the such. Heading back into the editor, under the camera object, we can now see that our script has been populated. We will need to drag the player transform, the parent, under parent transform. Now, when you hit play, your mouse movement will work correctly. Looking left and right will move the player to follow, and looking up and down will rotate the camera around the player. This very much assists the player in movement, where they can look towards where they want to go. Here I am simply just adjusting the camera to better suit how I would like it to view the player. Now I'm just playtesting once again to see if this camera better suits my needs of what I'm looking for from it. And that, my friends, is how you make a very simple movement in third person with a camera controller. As always, thanks for watching. Don't forget to comment, like, subscribe, share the video with your friends if you found this helpful, and leave comments below about what you'd like to see in a future episode. I look forward to hearing back from all of you, and see you next time. Peace out.